All right, so the lecture today is on chapter 8, and chapter 8 is titled as database redesign. But other than the concept of database redesign, is actually introducing, using this particular chapter, some more advanced SQL language and how it can be used in different environment. And so let's take a look at the content. The most important actually topic I like to cover is this thing called it's called a correlated subquery, right? And once you understand that correlated subquery, and you are in the medium to advanced level in terms of your SQL coding capability, right? But that's not that easy. Every time I go into that correlated subquery myself, I have to be my head had to be clear. So if I'm not very clear, like now it's Thursday evening, I have a whole day meeting today already. It's not that easy to get your head clear. It's very it's very logic, right? So you have to somehow understand the logic behind the process in order to understand the query, right? So let's start with the concept called the database redesign. And as I probably emphasize a lot in our job as a modern database administrator, the possibility of us to create a new database is almost zero because we're always using existing database or convert one data set to another. But it is highly likely we're going to be doing this modification to an existing database or redesign. So there are some tips and kind of a spraying around knowledge in this particular chapter talking about database redesign. And you will find many different topic in this particular chapter. And I'll try to be brief and go emphasize on the key point. So this is a table showing a potential database. Originally, it was designed probably not as rigorous, and sometimes was designed because we are experimenting as a initial prototype database, and so we didn't use a lot of constraint to make sure the data are correct. But later we find some errors that may go into the table, and it will be a good exercise, to look at the table to see what's wrong with this table from your knowledge, especially from your knowledge of normalization. Right, this is one of the things why normalization is so important, and I just feel like well, maybe we should have a seminar course focused only on normalization, but that will be probably too academic. But normalization does give people a very sharp eyes on how to test or detect database error. So if you can see this table and find the error right away, inconsistency or problem with this particular table, then you're great. But let me just tell you very quickly from the recorded lecture purpose. The problem is on the third rows of the table. If you look at the department phone number, the department phone number was accidentally enter one extra zero, right, into the table. So for the finance department, and we now have a problem, and this the problem here is obvious because the phone number in the United States system is always 7 digit, right? So 7 digit, excluding the area code. But this one that you have an 8 digit phone number, so that's obviously a data quality problem, or data called a data anomaly. And so if you think about what is the root cause of that particular data problem, it could be that data entry. So when somebody type in the department phone number, you enter one extra zero in there. But the other question is why you allow people to enter one extra zero in there. Can you design some sort of a database system so that the user can only enter 7 digit instead of 8 digit, right? So of course you can do that. And typically in a database environment, you can do this constraint or in a more general term, we call the data validation or data validation function or feature. This data validation can be done in several places. One of the commonly done places is at the front-end user interface layer. So if the data entry form is from a web form, so on the web page you can sort of like set up the format of the data. Sometimes in application we call this filter. You can create a filter in your data entry field. So when somebody put in the A number, it will not be allowed to type into the A number. So that is one possible way to do that. But there's still, because the data will be passed from your front end, either web page or application, to through some sort of a network environment, and then go into your database. And maybe somewhere in between there will be another place that you find problem. The other potential problem will be, say for example, all these numbers here are supposed to be number, but when you capture something from the web page, you capture text. So a lot of this web application, they do not differentiate between text and number. So number and text are actually treated the same. And those property, so-called data property or data definition, is not handled on the front end. Yes, you can write a program to check that validity or data quality or data type for your data, but sometimes some incorrect information will slip in here. This is especially true in this example, phone number. And we know that in the practice of in the United States, we sometimes use letter to represent the number. I don't know if that makes sense. You can have, say, for example, my phone number is actually on the web page, is not on web page, on my syllabus is A15 forgot the number, 575 9245 or something. But actually that number I actually pick very carefully. The last four digit of the number, if you convert into this letter 9-button cell phone letter system, the last four digit of my phone number is actually WANG, or WANG, WANG. That was picked intentionally. So it's a common practice that we can allow people to enter either numbers or enter the character to represent the phone number. So it will be captured as a string property of a variable. But when you send it to the database, when they record the data, and that may create another problem as well. So what format you want to enforce on the database and what format you can enforce on the front end is really up to the designer. But if you remember that we mentioned in chapter 7 already, the preference of ensure the data quality is on the server end, not on the user end, right? So you would rather enforce your database definition on the server when you create a table instead of on the Java or any application you build, or even Apex application you build from the user side, right? So the problem becomes that we know that this particular table, when it was designed originally, they did not define the constraint or data type or data domain very well for the department phone number. So it's very likely you need to check and modify the table to make sure that in the future, when somebody enters the number, it will be entered correctly. But before we even can modify the table, the first thing you want to do is to check how many potential errors that you might have. So this sample table that we created has only 7 rows of data. What if you have like 7 million rows of data? It's almost impossible for human eye to check every row to make sure the data quality. So in the database environment, you need to check the data quality using the utility provided by the database administration engine, or DBMS. So a lot of this good tool we have today, Oracle, the SQL Server, they all have this utility button. You can check to see if any outlier, any data quality check. But there's still something that wasn't detectable by the DBMS. So in that particular situation, in this case, this phone number, because you defined the value incorrectly, so somehow you have to find a way to detect those potential problems. So one of the important query method, and this is a very controversial, has been used, I should say, by a lot of database administrator or database knowledge worker to check their database. Is this a correlated subquery? It is controversial because this type of query is very resource demanding, meaning that when you issue this kind of query, it is a big old square in terms of the performance. I don't know if you heard about this thing called the Big O. Big O is the way that in computer science, when we try to assess the resource or the computation complexity. So if you have a big O square, it means that it is everything. Every computation is actually square is actually higher than the big O, big O1, big O2, big O square, different. So it depends on how you write your program. Your program can be very computation intensive or not so intensive. So this can create a lot of intensive computation performance problem if you do not use it correctly. So a lot of time that the correlated subquery have to be also issued on the server end, assuming your server has to be very powerful in most of the time, right? So that's but for most of the database, DBMS engine, Oracle SQL Server, and so on and so forth, they also give you their so-called modified or optimal algorithm to handle this type of request, and this optimal is usually handled in the exist or not exist keyword, and now we will take a look at those two as well, right? In this lecture with the recording format, I don't intend to make sure that you can totally understand or capture the essence, but I would like to point you to a few important kind of key places to make sure you do not make a mistake when you issue this type of query. And you can give it a try when you work on your project. That would be a good place to try this this query. And because the sample query we see here, we already know the answer. So when you enter this query, then it show up, of course, correctly. But you want to test this query in your project. That I hope you can bring back when we discuss your project and see if you actually utilize this type of query to check your data quality. Right. So this slide shows you a typical query. We call it subquery, and it's nothing special. So the logic here, and I try to explain this as much as I can in plain English. So we're dealing with this gallery, this little gallery problem we've been encountering since chapter 4, I believe. And so we're looking at the artist, the name of the artist in here. And what kind of artist we're looking for? We're looking for the artist that creating the work called Blue Interior. So so in here, you use a subquery to find or limit the artist ID in the work table to find that particular ID, and you go into the artist table to find the name of the artist. All right, so that's pretty much what you're doing here. The reason you want to do this is because in the work table there is no artist name recorded in the work table, because artist name artist ID is used as a surrogate, actually not surrogate key, the ID dependent foreign key to serve as an indicator or ID dependent indicator for the work. So because there is no artist name, so you need to get the information from two tables in order to get a result. So that is the use of subquery. And when you kind of read into that, I believe you can understand that very well. But this one now is the main topic we are looking at in today's lecture. That is the correlated subquery. And the main difference between this particular subquery, this query, and the one before is on the line that you pay the attention to the two lines that have the from keywords in front of it. So what does the words go after the from are tables, right? So the first from you see in this query is from work. The second from of this query in the subquery is also from the work. So what you see here is the main query and the subquery all query from the same table. So the same table is actually queried double times. So it's kind of like a nested. I think that's terminology best described. It's a nested query on the same table. So on the parent query table, you query work. On the child query, you also query the work table. If you go back to the original, the typical subquery we have in two different tables, the first from is from the artist table. The second from is from the work table. So this is the main differences. So when you query the same table in both the parent table, parent query, as well as in the subquery, you actually in the programming logic, you create this nested double loop sort of algorithm that you learn probably in your programming class. Some of you might be a long time ago, but let's just try to refresh your memory by give you a very similar analogy. So I believe everybody know what is a bubble search in a typical programming language, right? So how do you, and it is a very typical assignment in probably the second, probably the fourth or 5 weeks of learning after you learn the program basic, and the professor will ask you to do a bubble search. A more cruel professor will ask you to do something called a tree search, and those are the double looping sort of an algorithm that you are looking at here. It is also a double looping here algorithm, but because the language structure is different, the query language by the definition itself, every table is already two-dimensional. So when you query the table twice, then you are actually creating a double loop. In the typical programming language, the array is usually one-dimensional. So when you jump one step at a time, one loop is one step. You go into the child loop or the inner loop, you create the second dimension called the second dimension that create like a two-dimensional loop. So in here that you have automatically create two-dimensional by a table. So every query is already two-dimensional. When you query the table twice, you create a double loop, right? So that's what's going on here. So so that is the analogy between the bubble search and correlated subquery. But again, because their language structure is different, that you have to be very careful. And this is especially true for me as I was a programmer before I studied database. It become more confusing to me. But if you're not actually a good programmer, this is actually make more sense than the programming language itself, right? So the meaning of this particular query is the following, and the key is under the constraint or the where statement. So if you look at the where statement that we have, W1 represent the first outer loop. W1 and W2 are the same table. So we're looking at the logic of, we're looking at within this particular table, the title of the record is the same, but the work IDs are different. So in other words, we are looking at, say for example, we have somebody, or in the Louvre Museum, we have this work called artwork called Mona Lisa. Right? Last week I used Mona Lisa as well. So Mona Lisa. So if you have, maybe you have Mona Lisa in your database, but there are multiple Mona Lisa with a different um, product number, or in this case work ID. So 001 Mona Lisa, 002 is also Mona Lisa, right? So you have two Mona Lisa with two different, in this case will be what, more like a surrogate key, right? Surrogate key is supposed to be unique, but you have you have two different surrogate key but pointing to the same work. There, in the human intuition, you find something wrong in there. So that is exactly what we're looking at. So title are the same, but work ID different. You are looking at sort of like a duplicate copy, duplicate record of the same artwork in your database. Right. So that's the rationale that we are looking at in here. So that is this is of course the query result from your textbook sample database. So as you can probably see that we have farmers market, Spanish dancer, servant, the bird, and the fiddler. All of them are having different work ID, and in this case, the meaning behind it is that they are producing multiple print or multiple copies of the same work, because they are not selling the original work, they are selling the duplicate of the original work. So each one of this duplicate has a unique ID, and in terms of their copy, there are different copy number. So this leads to another question. Maybe you can find the same title has the same copy number, and that may be another query to test. But I test actually that query already. Instead of using the work ID here, use work ID here, you use you try to enter the copy number in here. Try to see if you can identify different same copy number, different word, but actually not that. Same copy number, but what is that? Same title and the same copy number. If you can find that, and that will be a potential data quality error. Right? So that is something that you can try. But in this case, there is no duplicate in the copy numbers here. So don't. Oh, I'm sorry. Same copy number, but different copy number with the same work ID. I should say, put copy on the title and put the work ID as in your query. Try to see if you can do that. So that will be a kind of introduction or example, very good example of showing you how correlated subquery can be used to double check the data quality. So in this case, we are checking the duplicated value that you are looking at for the same ID, right? So that is a potential problem. So that is the key for the correlated subquery. And one exercise I can probably recommend you to do is that if you recall that when we are looking at our Sims Club membership database, you may want to try to check to see if you have duplicated membership numbers in your database. I think that in the past the people have done that, and you can even do that not in the Oracle environment. You can go back to the University of Arkansas and do the data checking in their environment. And this is the exercise I actually used this particular example, try to test when I was working for a consulting firm, and we were recruiting the person know how to write SQL. I actually took this problem to as a screening method to see if how good my candidate is in terms of using SQL. Right? So try to play around that, and to the point that you feel you had enough, then that's good enough. Right? So this is the a common trap, and reading the slide does not give you you won't see the problem from the query. right? So let me tell you exactly what is the problem in the query. The problem in the query is that the work ID you are looking at, right? Work ID. And work IDs are supposed to be unique in this case unique, right? So you have a work ID and let's kind of compare the difference between these two. See if you can see the a small difference between them. So this one you have work ID difference here and title in here, but the where statement here, right? Where statement here is title in the title, right? And when you go into that common trap here, you look at the where statement. The where statement now is work ID. The rest of the query are the same, but work ID is in here, and this is a common trap. And the best explanation I can give it to you why this is a common trap is because work ID is supposed to be a unique value. It is a surrogate key. So when you try to use a where statement, put a unique value in here, it's always unique. You will always find the empty set in here, right? So the result will be an empty set. So you thought you don't have any data quality problem. It's not. It's not the case. It is the logic of your query is incorrect, right? So that's and going back and forth, try to see if you can see the differences. And so there are a couple of plays you want to maneuver in a query. The first one, and the two places are the table after the from. Make sure they are the same, and the important logic are hidden in the to where statement. So compare the to where statement, you will be able to identify or discover the logic of the correlated subquery, right? So the similar logic and can be used in many different places. And this is an example of you can use a correlated subquery to check the functional dependency and try to make sure that once you know the department name, you know the department number right away. In this case, you can find that some department has multiple number, and this is also called multi-value dependency problem. Can also be detected through the correlated subquery. And the better way of writing the correlated subquery is not using and this is the traditional way, using the to where statement and select from the same table to generate this double loop, double checking survey algorithm is the traditional way. But a better way to write a correlated subquery is using these two keywords called the exist and not exist keyword. It's basically the same algorithm, but the difference is that when you are using the exist and not exist keywords, the database engine optimize your algorithm and run faster, right? This is according to Microsoft, right? So Microsoft says if you use exist, the query will run faster. I read this from one of this user forum they have on their website a long time ago. So it makes sense. So when a database management engine that create these keywords for you, they want you to use those features provided by their language or by their engine. So their engine, of course, are written by the very well-trained programmer. So their logic, their algorithm training must be better than average people. Well, unless you are very proud of your coding or algorithm ability, then using the company provided engine is probably a better idea. So this is the key, one of the key points. And the logic of using exist or non-exist is actually the same as using the where statement that we use the conditional statement in the where to limit the matching between one set of the value to another set of value. And in the correlated subquery, we use the keywords in to compare one set to another. In database engine, you can use exist to compare one set to another. So the major difference is you, instead of using a logic statement in the where the parent where statement, you change that to exist or not exist. Exist and not exist, of course, is the opposite logic, right? So you can use this when you are clear about what you're trying to look for. So we are looking for an employee exists in the resulting that has a condition of department is the same, but the phone number is different, right? So that's what we are trying to look for in here, and that will be a potential place you find data quality problem, right? So if unfortunately or fortunately in the future your job is the data preparation role or data quality control type of person, and you have to be very good at reading those. And of course, in some working environment, these will be written by the more experienced the data quality worker, but you should expect yourself to be one of those persons. Right? So exist replace the in statement in the correlated subquery. A more complex logic can be applied to so-called double not exist. Exist in one set but not does not exist in another set can also be applied. And this one take a while to really understand what they're trying to do here. But again, the key is looking at exactly what kind of table they're looking at, right? So this one has triple loop or three layer or three nested layer. So the key is try to look at which table are used doubled or as a nested table to compare. So the first loop or the inner usually we look at this logic or nested logic from the inner loop first. The inner loop compare the front table. We have customer artist intersection table, customer table in the intermediate parents, and we have artist table in the parents. So we have three different table that you are query. But where is the correlated subquery is coming from is that the correlated subquery is looking at the customer artist intersection table. So the customer artist intersection table is the one being double loop and double run twice to generate a set of customer ID that used to be compared to other layer of correlated subquery. Right? So that is something that can be used as an example, but very rarely you will see people use this double not exist environment. So I would not encourage you to try this because if your logic is incorrect, you always come up with incorrect result. So I would recommend just use a simple not exist or exist logic will be good enough for your practical use. And for more complicated comparison, use what? Views. You already learned that in a couple of your assignment from this semester. So use view instead of use double loop not exist logic to compare, to double check your data record from one table to another. Okay. So that's the one of the most important topic in chapter number 8, correlated subquery. The rest of the chapter talking about some of the tricks and some of the issues that you may encounter in database redesign. And one of the job that I asked you to practice in your project assignment is to recreate a thing called the recreate data model. And this is the purpose of why we are learning ER model in a graduate level class like this one, because once you be able to understand data model and be able to discuss the constraint, the multiplicity or actually cardinality between different entity and how you enforce constraint for each relationship, then you are in a good position to identify potential data quality problem, right? So when you are introduced into an environment you're facing a brand new database you do not understand. Like in the case of our project, you are introduced to a bunch of table that you do not understand the data structure. The first thing you to do is to understand the data structure. The good news in a enterprise environment, say for example, going to be using SAP or any enterprise system, you don't know about data structure, but somebody asks you to retrieve data from that database. The first thing you can do is most of these environments provide something what we call reverse engineering capability. So reverse engineering can be used in many different places in software development as well. Nowadays, that a lot of these UML tool will be able to read a computer code that is not protected and reverse engineer back to the original data structure or program structure even from the source code. And in database environment, the excuse me, the database structure can be reverse engineered by these engines as well. So that is actually a very nice and neat feature to do so. Now the engine like Microsoft Access, SQL Server, and Management Studio will all have this capability. This is especially true if you use Microsoft Access. They automatically generate this data model for you. And in our SQL Developer, they also have this tool. Once you have this data implemented into your database, you can generate a relational model or something called a data model to represent the data. Now, the data model look a lot like ER diagram. Actually, they are using the crowdfoot notation as well. But there is a main difference. The main difference is the data model usually have your implementation detail, the key, the foreign key related to one table to another being assigned to you. So one of the jobs when we approach a new database is always to recreate this data model, and this is a process we call re-engineering process. This can be done manually and can be done automatically by many database engines. But in our project, you are trained to do this manually. I may show you how to do this semi-automatically in one of our sessions when I make sure that my demonstration works smoothly. Now I'll try to show it to you, and it will take a little bit too much time when I try to play around and show you the correct way. But I'll try to give you one example of how SQL Server environment can automatically generate these type of data structure. Say for example for the Tyson Food database, and you can read and understand the data set more. And there's another database diagram called the dependency graph. Show how one element depends on the other in terms of their relationship. This is again not a ER model, but it shows how this table can kind of work together. A lot of these dependencies are based on the constraint of the data table. And the notation, if you remember very well on the from the UML class that we have in this program, you probably understand what those diamonds mean, right? This is you can call this a square. Yeah, I'll rather call this a diamond shape in the relationship. Diamond shape usually represent the many side, right? Many side. So think in that way, and it is a relationship we call the aggregation relationship in a class diagram. So if you recall that what you learned in MIS552 from the UML model, then this is the aggregation or composition relationship we're talking about. And it will be very useful to see how one table depends on another in terms of the value or the key relationship between one another. And there is no many to many, it's always one to many in the relationship or dependency graph, because in the real world implementation, it's always one to many, no one to many relationship. Right? So once you have understand the database structure, And sometimes you detect a problem from the structure, and you realize that in order to enforce, say for example, the duplicate telephone number situation that we have for the sample database in this chapter, you want to uh, change the constraint to make sure that you can enforce that at the database level. And to do that, you have to follow a few logic to make sure that you do not destroy the original database, or you will not lose any data during the process of modifying your table. Because a lot of time when you try to delete a column or even add a column into your database or change the name of the column, you change the or destroy the entire structure of your database. So there are a few situations your textbook summarize and ask you to be careful and know what is the correct process or correct logic to make sure the change does not impact in particularly operational database. These including change the name of the table, change the name of the column, change the value, or drop the table, drop the column, change the constraint, and so on and so forth. And the rest of the slide I'll go relatively faster just to give you some basic understanding about how to do that. And the textbook, of course, using the opportunity to introduce you how the data definition language and data manipulation language are used together to kind of going back and forth, and you be able to control the database more correctly. And so this is the process. So this first example is changing the table name. Changing the table name, of course, is very dangerous. If you try to change the table name, and earlier we look at our assignment has a table called Titanic. And if you change it to Titanic 2, the whole report will not work anymore. So the application and some other table may depend on your table name. So there is a thinking process you have to think about. One of the most safe way to do so is what? When you try to change a table or modify anything, always create a backup, which means that you duplicate the table instead of modify the existing table directly. That's probably the safest way. So this is actually the step talking about when you change the table name. Keep the original table, and then you can modify the table based on the constraint, and modify the new table instead of the old table. And use the new table to test first. If everything worked well, then you replace the new table. And I will still keep a copy of it. The modern database design, if you or database engine, if you choose to trace all the history that you have done in your system, this type of duplication, whenever you try to drop something, is automatic. But of course, if you use our Apex environment, it is not. You will not. Your old data will not be backed up automatically. But again, like I said, in your database, and say Oracle 18c, by default, all the data structure change will be kept a copy on the server, so you can always roll back to make sure the original table is there. But a lot of database administrator, in order to improve the performance faster, they turn off that automatic recording feature or rollback feature. That is when situation become dangerous, when you try to delete table, change the table name, and do some other thing in the job we are doing here. Right. So create a table, modify the constraint, and copy the data is the process they're introducing here. Adding a column, similar to kind of adding a table, use the alter keywords, alter table keywords, and you add a new column. Adding a new column is usually not a big issue here, unless this column will be used as a key for future use. Especially in this case, add a null column. Just make sure you have a nullable column property here will be good enough. If this is not null, you want to create some default value, then you create a nullable column first, and then add non-null afterward by alter or using update table to do the job. And the difference between this is actually an exam material. You could probably find one of the quiz questions talking about this. The difference between alter and update is alter is alter the definition. Update is update the value. So that's the difference. Definition and value. Right? So one is a structure change. The other is value change. Structure change usually have more profound implication in there. Now, similarly, well, earlier we talked about just using this opportunity to compare. We learned that in data definition, when we try to delete a table, we have drop table compared to truncated table. Truncated table is drop all the record, but not the definition. But drop the table will drop the definition. So the similar analogy is using here. Alter is modify the definition, but the update only change the value. Right? So that then finally the process, the last one, you modify that to a not null. So this is a typical process of adding a not nullable column in a database. Now, if you want to drop is more dangerous than adding a column. Now, to drop a column, then you have to check the value, the dependency first before you can drop. So you want to make sure all the foreign key are dropped first before you drop the parent ID. That's the basic rule of thumb. And some of the modern database will not allow you to do that, or it will give you a warning that says, do you want to cascade your drop from the table? The word cascade means that if you drop this one, the child table, the ID dependent table will all be dropped. Right? So a lot of times that create a lot of disaster when you accidentally drop or delete the key from one table. So the SQL alter key is used to do a lot of these constraint and drop, and I will not go into detail how to write this, but this is a change of constraint. You can do that using alter key as well. Again, alter is a definition change, and update is only value change, right? So that cardinality change, similar to the key drop, you have to modify the nullable property of one key to another in the process. So the parent have to be modified something. On the child side, you have to do something to make sure they are consistent to when you modify multiplicity. And these modifications, go through a few slides and just let you know they're pretty much talking about the same thing. So when you modify the relationship cardinality, that you have to make sure that usually parents, when you modify parents, you start from the child and then go back to the parents. That is the sequence. Now this is more significant. When you change from one to many, or one to many to many to many, this have to create a new table. So you have to create a new table before you can modify and drop the table. So you need to use the keywords create a table, and then using the key insertion to create a new table. All can be done by the data definition language that we have learned so far. These hopefully that will become useful, so you know at least where you can come back and find reference of these work, and so you have an opportunity to preparation. Again, most likely if you work as a person preparing data for the data analyst, you will be doing this type of job. Or if you work as a DBA, people will come back and ask you, how do I modify a table? How do I change the structure of the table for the people who want to access your data can make sure they've done a better job. Right, so that is, I think most of them are looking at similar thing. Finally, the keywords called forward engineering. We have reverse engineering, we have forward engineering. Database engine can do the forward engineering as well. The only difference is forward engineering usually will forward engineer only the definition, not the value in the database design. So that will kind of Yeah, if you think about it, when you design something in a database, you usually will not have data to come with your design. Database design is an empty shell. So forward engineering will have only uh, empty table created. But reverse engineering, you might be able to get some information about how many record, how many row you have in your database, as well as your data definition, table views, sequence object, all these things that exist in your database. Right. So that's pretty much all the content in chapter number 8, talking about some advanced SQL language. Most importantly, correlated subquery. Hopefully you at least remember the name. So when people are talking about correlated subquery, you remember the keyword exists and not exist, and you remember this double loop algorithm, and understand there are important implications whenever you change the definition of your database structure. You have to be careful, make sure you do not impact the data quality of your database. And that's it. And that will be the conclusion of chapter number 8.